In this video, we will review the cooling capacity, electrical consumption, working pressures, and capillary tube of the 1/4 HP compressor that uses R134a refrigerant gas. 1. Let's start by saying that the cooling capacity of a compressor mainly depends on the temperature required at the evaporator. 2. On average, a real 1/4 HP compressor operating with R134a has a cooling capacity of 940 BTU per hour, 237 kilocalories per hour, when running at a temperature of -20 degrees Celsius -4 degrees Fahrenheit. 3. However, if the temperature is -10 degrees Celsius 14 degrees Fahrenheit, the cooling capacity increases to 1549 BTU per hour, 390 kilocalories per hour. 4. Now, regarding the electrical consumption of the 1/4 HP compressor, this mainly depends on the supply voltage. For a compressor powered at 120 V, the current consumption will be approximately 2.15 amperes. Meanwhile, for one powered at 220 V, the current draw will be about 1.17 amperes. 5. The working pressures of the compressor running with R134a can be checked using our simulator. First, we will set a condensation temperature of 45 degrees Celsius 113 degrees Fahrenheit, a superheat of 5 degrees Celsius, a variation of 9 degrees Fahrenheit at the evaporator outlet, and a subcooling of 5 degrees Celsius, also a 9 degrees Fahrenheit variation at the condenser outlet. 6. Remember that the link to access our simulator is available in the video description. 7. If we select an evaporating temperature of -10 degrees Celsius 14 degrees Fahrenheit, and considering an altitude of 500 meters above sea level, we will obtain the following pressure values. 8. Now, if we choose an evaporating temperature of -20 degrees Celsius -4 degrees Fahrenheit, for the same altitude of 500 meters, the pressure values will be as follows. 9. Next, we will search in our simulator for the appropriate size of the capillary tube. Let's start with the capillary tube for an evaporating temperature of -10 degrees Celsius 14 degrees Fahrenheit, remembering that in this case, the compressor's cooling capacity is approximately 1549 BTU per hour, 390 kilocalories per hour. Under these conditions, it is recommended to select a capillary tube whose length is close to, but still below, 2 meters, about 6.56 feet. 10. Now, we will do the same for an evaporating temperature of -20 degrees Celsius -4 degrees Fahrenheit, where the cooling capacity is around 940 BTU per hour, 237 kilocalories per hour. Similarly, it is suggested to choose a capillary tube with a length close to, but still under, 2 meters, about 6.56 feet. Remember that the link to access our simulator is available in the video description.